Okay, welcome to question 2 of the Year 12 PPE. This is a question about vectors, and we have here a situation where the Coast Guard station at O monitors the movements of a small boat. At 11 o'clock, the boat is at the point 4 minus 2, effectively is what that means. So I'll just mark this up here as 4 minus 2. Okay, 4 negative 2. And that's at 11 o'clock. And then at 1:15, that's 2¼ hours later, the boat is here at -3, -7. Okay, -3, -7. Okay, so the position vectors are effectively relative coordinates to O. So O is somewhere in the middle here. We can deduce that from the coordinates. In fact, it'll be up here somewhere, in fact, between these two and up here. But that doesn't really matter to the problem. Okay, it says that we have to first of all calculate the bearing on which the boat is moving. Well, it's moving in this direction, so it's sort of going southwest. So the bearing is going to be made up of 180 degrees plus this angle here, which I'm going to call theta. And we should be able to say from our diagram that the tan of theta, okay, the tan of theta is going to be the opposite over the adjacent. Well, the opposite, if you look at the difference in the x coordinates, is 7. Okay, and the adjacent it's going to be the difference between -2 and -7, which is 5. Okay, so it's the inverse tan of so tan theta is 7/5. Okay, 7/5. Okay, and if you put that in the calculator, that gives you that theta is 54.5 degrees, okay, to 1 decimal place. That's the actual angle, okay, and therefore the bearing is going to be that number plus the 180 degrees that takes you from north to south. So the bearing is 180 plus 54.5, okay, and that gives me 234.5 degrees. Okay, so basic right-angled trigonometry there. And then we have to work out the speed of the boat. Well, we need to know the distance, okay, and the distance, of course, is the square of the squares of the two short sides added together and square rooted using Pythagoras. Okay, so if I just start with that, I can do the square root of 7 squared plus 5 squared. Okay, and that will give us the distance of the hypotenuse of that triangle. Okay, that comes to root 74. Okay, so I'm keeping it in exact form at the moment, and the speed is therefore going to be the distance divided by the time, which is going to be root 74, okay, over 2¼ okay, because it's 2¼ hours between the two, so 2.25, and on your calculator you can work out that that's 3.82 kilometers an hour to 3 significant figures. Okay, and that's a reasonable degree of accuracy to give for that sort of question. But all the working's clear and you've shown how you've got your answer. Okay,